Good morning, students. Today we are going to discussing about adsorption theory of heterogeneous catalysis. Already last class we are discussing about catalysis, what is catalysis and what are the types of catalysis already we are seen. So now today we are going to discussing about adsorption theory of heterogeneous catalysis. Already we learned that homogeneous catalysis and heterogeneous catalysis. Heterogeneous catalysis is nothing but the reactant and catalyst will be exist in different phases. Different phases existing means that is called heterogeneous catalysis. So different phases presented mean this called as heterogeneous catalysis. Now we are going to discussing about adsorption theory of heterogeneous catalysis. So just look at here all of you once. Yes. So this theory explains the mechanism of heterogeneous catalysis. So heterogeneous catalysis, what are the adsorption steps will be presenting there. So that steps and all now we are going to seeing there. So the old theory known as adsorption theory of catalysis was that the reactant in gaseous state or in solutions are adsorbed on the surface of the solid catalyst. The increase in concentration of the reactants on the surface increases the rate of reaction. This is underline this point. So increase in concentration of reactants on the surface increases the rate of reaction. So that means concentration of reactants is increases means concentration of reactant surface is increases means rate of reaction also what happen increasing is takes place. Adsorption is being exothermic process. Already we learned that. So adsorption process what do you call me exothermic process. That means amount of energy what happen releasing is takes place. Amount of energy will be releasing is takes place. The heat of adsorption is utilized enhancing the rate of reaction. So the heat of adsorption what happen enhancing, that means increasing is takes place. So where it will be increasing mean to increase the rate of reaction. So rate of reaction increasing purpose what happen means this adsorption will be takes place. Heat of adsorption will be utilizing for that. The catalytic action is explained in terms of intermediate compound formation. So catalytic surfaces and all how we are going to explain it means by using some intermediate complex state then only we can able to explain about here adsorption adsorption process. The modern adsorption theory is the combination of intermediate compound formation theory. So that means this intermediate complex formation is known as combination of intermediate compound formation theory and the old adsorption theory. The catalytic activity is localized on the surface of the catalyst. So what are the mechanism will be involving in this adsorption mechanism means there are totally 5 steps will be involving there. So step 1 what you are saying means step 1 diffusion of reactants to the surface of the catalyst. From surface onwards what happen catalyst diffusion is nothing but escaping. So diffusion of reactants to the surface of the catalyst. That means so reactant and reactants and here surface catalyst what happen mean weak force of attractions will be presenting there. So because of this breaking of this bond between the catalyst and here reactant surface, so diffusing is takes place. Diffusing is nothing but easy to escaping nature. That means the reactant molecules are escaping from the surface of the catalyst. Next, second step. Adsorption of reactant molecule on the surface of the catalyst. So reactant molecule under what happen, easily it will be adsorption will be takes place with the surface of the catalyst. Second point. Next, third point, see there, occurrence of the chemical reaction on the catalyst surface through the formation of an intermediate. So third step, what you are seeing, intermediate formation we are going to seeing there. Next, coming to see that fourth point, desorption of reaction products from the catalyst surface and thereby making the surface available again for more reaction to occur. So fourth step, what is desorption? Desorption is nothing but the intermediate compound generally always what happen means unstable in nature. So this unstable intermediate complex what happen mean try to desorption. Desorption is nothing but easy to breaking that intermediate compound, right? Next, fifth step. So fourth step, what happened? Desorption will be takes place. Desorption is nothing but escaping nature will be takes place. And fifth step, what happened means diffusion of the reaction products away from the catalytic surface. So catalyst and product and what happen, easily it will be deviating is takes place, separating is takes place. So this is totally how many steps will be involving in this adsorption mechanism means totally 5 steps will be presenting there. So step 1, what happen means reactants is far away from the catalytic surface. Second step is reactants will be adsorption on the surface of the catalyst. Third step, what happen, intermediate complex formation will be takes place. And fourth step is desorption of the reactant molecule from the surface, catalytic surface is takes place. Fifth step is diffusion of the reaction products away from the catalytic surface. So totally 5 steps will be involving for this adsorption mechanism. So let us see that diagrammatically how we are able to seeing, how we are explaining there once. So this is step 1. Step 1, what you are observing means here catalyst surface having free vacancies will be presenting there. That means this dots under what you are saying free vacancies. So this free vacancies under what happen means it will be easily adsorbing is takes place by the reacting molecules, right? So this is catalyst under what is solids catalyst having free vacancies will be presenting. So this free vacancies under what to happen means reacting molecule will be adsorbing is takes place. So after adsorption what will happen means they will form this like this compound. This is step 2. Step 2, what happen means adsorption will be takes place. So the active sites of catalyst will be easily adsorbing these reactant molecules. After adsorption what you are seeing means the A and B. So A and B reactant molecule what happen, it will be strongly bonding is takes place with this catalytic surface. Next, step 3. So step 3 what you are seeing means here intermediate compound will be forming there. So intermediate compound is nothing but the 2 reactant molecule in between, here one new bond will be forming there. So because of this new bond what you are saying intermediate complex will be forming this. So this intermediate complex under what you are seeing means unstable in nature. So again further what happen means the bond cleavage will be takes desorption will be takes place from catalytic surface and here reactant molecules. So that means these bonds will be breaking is takes place at the fourth step. So after desorption of this AB molecule from the catalytic surface, They are diffusing each other. Diffusing is nothing but catalytic surface and product molecule and all what happen, it will be separately will be escaping is takes place, diffusion. So this is overall how many steps will be involving. Step 1, reactant molecule and catalytic surfaces will be far away distance will be present. Second step is due to because of adsorption from the catalyst and adsorption reactants, they will approach each other. Adsorption will be takes place. Third step, what you are seeing, intermediate compound will be forming there. And fourth step is desorption of the product molecule will be takes place. And fifth step is the product molecule and catalyst and all what happen, far away distance it will be spreading is takes place. So this is what you are saying, adsorption mechanism. Adsorption mechanism. So totally how many steps will be involving in this adsorption mechanism means totally 5 steps will be involving. So because of these 5 steps only what happen, adsorption will be takes place from reactant molecules and the catalytic surfaces. Next one, see there some important features of solid catalyst. So solid catalyst, what are the major important features will be must be need. So first one, see that activity and another one is called selectivity. Activity and another one what you call selectivity. There are two important features of your solid catalyst will be presenting there. So now coming to see that first one, what is mean by here activity? What is mean by here activity? So activity is nothing but the activity of a catalyst depends upon the strength of the chemisorption to large extent. So activity majorly where it is depending means chemisorption, that means how much strongly the force of attraction will be takes place from the reactant molecules and catalytic surface. So depending on this strength of the chemisorption only what happen means activity will be depending there. So the activity of catalyst and all where it is depending means it is depending upon the strength of chemisorption to large extent. The reactants must be get adsorbed reasonably strongly on the catalyst to become active. So that means the reactants and all what happen very strongly chemisorption is happening means chemical bonds will be forming. Due to formation of these chemical bonds what happen means they are very strongly bonding is takes place from the surface and the active sites of your catalyst. However, they must not get adsorbed so strongly that they are immobilized, and other reactants are left with the no space on the catalytic surface for adsorption. So that means mostly all reactant molecule what happen means very strongly bonding is takes place. So there is no space for that further adsorption is happening. It has been found that for hydrogenation reaction, best example what you are saying means hydrogenation reaction is the best example for that. So the catalytic activity increases from group 5 to group 11 metals, with the maximum activity being shown by group 7, group 9 elements of the periodic table. So that means maximum adsorption which elements will be showing means 7th group and 9th group elements. 7th group and 9th group elements and all shows here maximum activity in nature. So catalytic activity is increases. Whichever group elements will be increasing this catalytic activity means group 5 to group 11. Group 5th group to up to group 11 elements and all what happened, maximum activity and all they are showing there. So just example is given, just look at here, hydrogen plus oxygen to give rise water molecule. So here what will be their activity? Activity is, so what catalyst we are using means here platinum. Platinum under we are using there. That means this is belongs to here group D block elements. D block elements. Next one, see there, coming to see that next another one. What is mean by here selectivity? Selectivity is different. Activity will be different. Activity is nothing but active centers of the catalyst. Next, coming to see this selectivity. The selectivity of a catalyst is its ability to direct a reaction to yield a particular product selectively. The selectivity of a catalyst is its ability to direct a reaction to yield a particular product selectively when under the same reaction conditions many products are possible. Selectivity of different catalysts for same reactants is different. For example, starting with the hydrogen and carbon monoxide, the using different catalysts and all, we get different products. That means finally what you are seeing means here using here reactants and all, what happen, different quantities you are taking there. 1 mole of hydrogen, 1 mole of H2 and 2 moles of hydrogen, 3 moles of hydrogen, like that different quantity of your reactants and all we are taking there. So different quantities of reactants we are using there. So and here what you are using here, different kind of catalysts also we are using there. First reaction carbon monoxide plus 3 moles of hydrogen reacted means in presence of nickel to form methane plus water molecule will be forming there. Carbon monoxide plus 2 moles of hydrogen is combined to form in presence of copper or zinc oxide or chromic oxide mean to form methanol will be forming. So third step is carbon monoxide while react with hydrogen in presence of copper to forms formaldehyde will be forming there. So that means under the same reaction condition many products are under what happen possible. So reactants will be different, but due to because of your suitable catalyst, different kinds of your products will be forming there. So this is called as selectivity. Selectivity. So the action of catalyst is highly selective in nature. As a result, a substance which acts as a catalyst in one reaction may fail to catalyze another reaction. That means one catalyst and all only utilizing for only one reaction only. So one catalyst does not catalyzing here to more than one reactions and all. So this is about here selectivity. Selectivity. So tomorrow class we are going to seeing that shape selective catalyst by zeolites, enzyme catalysis. So these things and all tomorrow, what are the characteristics of your enzyme catalysis will be presenting. I want to know what is the mechanism of your enzyme catalysis will be presenting there. So these things and all tomorrow class we are going to see, right? So thank you very much. So tomorrow morning again we will meet you again. Thank you all.